Hi everyone. In this video, I am going to give you the tools to solve this problem. And we're going to solve this problem by manipulating the given KCs to figure out the KC for a target reaction. Why do we need to manipulate KC is topic A. Kc being the equilibrium constant. The answer is to do Hess Law Problems. Do you remember Hess Law? You can add several reactions together to get a target reaction by canceling out compounds that appear on both sides of the reaction arrow. For instance, if my target is this reaction, 2A plus B equilibrium Y plus Z, and I'm given a couple of reactions such as Y plus Z goes to, is that G? G, and A plus 1/2 B goes to 1/2 G. Remember these types of problems where you have to manipulate the reaction? Last time we talked about Hess law, we were manipulating enthalpy, delta H, and then you add up all the enthalpies once you feel that you've arranged all the reactions properly. But in this case, we're working with equilibrium constants, and the manipulations of these values are going to be a little bit different than delta H. So we have the Kc of the first reaction and the Kc of the second reaction, and I'm wondering what is the Kc for the target reaction. And as you recall, you manipulate the given reactions, so when they add up, they give you the target. And the trick here, as a reminder, is, well, make sure that the compounds are on the correct side. So for this reaction here, it looks like I have to reverse to get the Y and the Z on the left. Sorry, on the right. So we reverse to get G goes to Y plus Z. And then we have, and then we're going to learn how do I get the new Kc. Kc1, and we'll call it prime. When you reverse the reaction, what do you do with the Kc? It's different than the enthalpy manipulations. But let me show you this equation. It looks like we have to multiply by 2. The A and the B are on the correct side, but we do have to multiply by 2 to get 2A plus B goes to G. And then you notice that when we add up these two reactions, before we do that, you have to figure out what the manipulation for Kc is going to be, Kc2 prime. But when we add up the reactions, you notice that G's cancel out, and we have 2A plus B goes to Y plus Z. By the way, let's assume that everything's a gas to keep things simple. So we're not going to write down the phases. Are you ready for the rules? What do you do with Kc if you reverse it? What do you do with Kc when you multiply by 2 or some other number to get the correct coefficient? And finally, what do you do to the Kc's to get the new Kc, the Kc of the reaction? Rxn, Rxn. Okay. That is part B, the rules. Rules for manipulating Kc. Okay, first thing is let's get us a reference reaction. And the reference reaction is going to be simply A plus B goes to, I already messed up, but we'll go with this. A plus B goes to C, and let's give this a value. Let's work with some real values. Kc equals 251. Remember, equilibrium constants have no units. So the first thing is reverse. So if we reverse, let's do it this way, and we get a new reaction. C goes to A plus B. Remember that Kc is what? Kc is the products. In 1 second. The products over the reactants. I was debating whether I should put coefficients, but let's not complicate things right now. We have that. So can you imagine that when you go in the reverse direction, now that our products are A and B, so what do? You take the inverse. So the new Kc, we'll call it Kc prime, equals 1 over 251. All right, so you'll keep track of these manipulations. You take the inverse. Real quick, for enthalpy, delta H, do you remember what happens when you reverse the reaction? The delta H changes by how? It changes by changing the sign, right? So when you reverse the reaction, you take the opposite sign. But here you take the inverse. Next is, let's say we have to multiply this original reaction by 3. So we do multiply by 3. That gives us 3A plus 3B goes to 3C. When you change the coefficient for an equilibrium expression, you know that the coefficient actually becomes an exponent. So the new Kc is going to be taking that factor that you multiplied the reaction by and make it the exponent, 251 to the 3. So you take whatever factor you multiplied by and you make as exponent. That's different. For delta H, you just multiplied the enthalpy by the number. So you did the same operation, but here you make that the exponent. Now, what if you have to divide? If you have to divide by 2 to get what? To get 1/2 A plus 1/2 B goes to 1/2 C. We're going to have a new Kc prime. Well, that is the same. Dividing by 2 is the same as multiplying by 1/2. So you're going to take 251 and you're going to put the exponent as 1/2. It's the same rule. Make it as the exponent, but you have to express your change as a multiplication. So if you divide by 5, that's the same thing as multiplying by 1/5. 1/5 goes as an exponent. Okay. Okay. What about this? What if we reverse and multiply by, I don't know, let's say multiply by 4. Oh boy. Okay, so we reverse and we get 4c goes to 4a plus 4b, and we have a new kc prime equals. You know that if you reverse, you take the inverse, and then when you multiply the coefficients by a factor, you raise it to the exponent. I'm showing you this example because on the calculator, it actually doesn't matter which you do first. Do you want to take the inverse first and then raise it to the power, 1/4 power, or do you want to take the kc, raise it to the 4th power, and then take the inverse? So I'm telling you, those two will give the same answer. Okay, it doesn't matter the order. I'll put that down. Order. It's literally the same thing. Order doesn't matter. The last thing. What if you have to combine reactions? Okay. Oh, goodness gracious. Let me give us a new given. What if we have C goes to D? Just real simply. C goes to D. And I have the given Kc. We'll call this Kc of 1, Kc of 2. Let's make this less than 1. Let's make it 7.6 times 10 to the minus 2. So if I want to add those two, okay, no manipulation, just adding those two. You see how the C's cancel out? So I get A plus B goes to D, and we can get a new Kc prime. We added the reactions. So how about I put here add two reactions. What you're going to do is you're going to multiply the two Kc's. Okay. Let me just make sure that makes sense. We have that. Yep, you're going to multiply. So let me write it down this way. Oh, we actually have numbers. So it's 251 times 7.6 times 10 to the minus 2 equals 251 equals times 7.6 times 10 to the negative 2 equals 19.1. You multiply the k's. I'll put it up here. Okay, not the best looking chart. When you go recopy your notes or when you study, why don't you clean this up? If you want, I used real numbers, but if you want to just use KC1 and KC2, and you say take 1 over KC1, or KC1 to the 3, or KC1 times KC2, you could also do that instead of using the numbers. But I like to see, what do I need to punch in the calculator to do this type of calculation. Part C is practice. And this is the problem that was on the cover. Part C. I'm not going to do this problem for you. All I'm going to do is give you the answer. And then you will do this at home and try to figure out if I made a mistake or if we agree. And the answer is this. The new Kc equals, or the kc of the target, 5 point, I hope this is right, 5.89 times 10 to the 20. Do I want to give you any hints? No, I think we're good. Let me just make sure. I think we're good. You know that if you raise something to the 1/2, or take the 1/2 power, that's the same thing as the square root. But I like to get in the habit of saying raise it to the 1/2, because what if you have to, um, uh-oh, oh no, did I do this wrong? I can't believe I did that. People, B, if you multiply by 4, it's not raise it to the 1/4, you have to, oh man, please, 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 please make that correction. How lucky am I to go back and double check? Alright, like I was saying, when you multiply by 1/2, that's the same as taking the square root. I was going to say I like to literally show raising to the 1/2, because what if you have to multiply by 1/4? Multiply by 1/4, but here I didn't multiply by 1/4. I literally multiplied by 4. 4 is the exponent. I'm going to have to do this video over again. Anyway, as soon as I stop this video, I'm gonna double check, and if this number is wrong, no one will ever see this video. I am gonna destroy it.